This is section 2.2 of Honors Algebra 2, solving compound inequalities. So in 2.1 we solved inequalities that are just basic number sentences with less than or greater than or less than or equal to or greater than or equal to. In this section we're solving compound inequalities. And the first type are called conjunction sentences, which makes it sound like we're in English class. In a way I guess we are, because these are sentences formed with the conjunction and. So conjunction sentences are and compound inequalities. And we can write them in two different forms. We can write them as two inequalities with an and in the middle, and we can write them as one three-part compound inequality like number 2 is. But what number 2 is really saying is 3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 15. But we just scrunch it all together and put that 2x plus 5 in the middle. We could do the same thing with number 1. We could rewrite it. What it's saying is negative 2 is less than x, which is less than 3. If x is greater than negative 2, then negative 2 is less than x, and x is less than 3. What compound and inequalities, these conjunction sentences, are doing is requiring that both parts must be true. And is saying we want one and the other one. We want both. Both parts must be true. On a number line, the way number 1 would look, we've got negative 3, negative 2, negative 1, 0, 1, 2, 3. If we want x to be greater than negative 2, then we're going to put an open circle at negative 2 because we can't include negative 2, and we would go to the right of negative 2. If we want x to be less than 3, we're going to put an open circle at 3, and we would go to the left of 3. But we want both of these things to be true. That means we're stuck in the middle between negative 2 and 3. Only in that section do we have numbers that are both greater than negative 2 and less than 3. And compound and inequalities, these conjunction inequalities, will generally look like that when we graph them. There's two endpoints, and we're stuck in the middle. We shade in the middle. On number 2, we have to do some work before we can graph it. We need to solve it for x. And solving a compound inequality means we get the variable alone in the middle. And what we do to one part, we have to do to all three parts. So I can subtract 5 from all three parts and have that negative 2 is less than 2x, which is less than or equal to 10. And I can divide all three parts by 2 to get that x alone in the middle. So negative 1 is less than x, which is less than or equal to 5. As a solution set, this means the set of all x such that negative 1 is less than x, which is less than or equal to 5. As a number line, this means I've got 0, negative 1, and 5 is over there somewhere. And I put an open circle at negative 1 because I can't include that. But I put a dot at 5 because I can include that. I've got less than or equal to 5. And then I'm stuck in the middle. X is anything in between. Is it just 0, 1, 2, 3, and 4? No. It's those and an infinite number of other numbers that are between those integers. So we have to remember that we've got all of those fractions and decimals in there as well. So we have conjunction sentences and we have disjunction sentences. Disjunction means they don't have to overlap. Okay, we'll take one set of numbers or we'll take another set of numbers. And we don't care. They don't have to satisfy both. So these are or compound inequalities, which means we'll take at least one set, or at least one, let's say at least one sentence must be true. They don't both have to be true anymore. In an and, in a conjunction sentence, they both must be true. In a disjunction sentence, we just care about one of them at least being true. So these always look like two separate inequalities with an or in the middle. We have to have that word or in there. Otherwise it's two separate problems. But this is not. This is one problem that has these two necessary parts. And we solve each of them separately. So if we solve the first one, x plus 7 is less than 4, we subtract 7 from both sides, and x is less than negative 3. Or we solve the one on the right, we get negative x is less than negative 6, which means x is greater than 6. I have to divide both sides or multiply both sides by negative 1, switches the sign. So I've got two parts with an or in the middle, and I need that word or, and my solution is incomplete. On a number line, that would be, well, here's negative 3. We'll say that's 0. There's 6 somewhere over there. We want x to be less than negative 3, so open circle at negative 3 and to the left of negative 3. Or we want x to be greater than 6, open circle at 6 to the right of 6. And these disjunction sentences, these or compound inequalities, will generally look like that. Two separate pieces going away from each other, two different branches going away from each other. Number 4. If we subtract 7 from both sides, we got 2y is less than or equal to negative 6. Divide both sides by negative 2, so y is greater than or equal to positive 3. Or 6 is less than negative y, which means that negative 6 is greater than y, which means that y is less than negative 6, if I just write the inequality in reverse. So I've got y is greater than or equal to 3, or y is less than negative 6. Graph it. So I've got a negative 6, I've got 0, I've got 3. I want y to be greater than or equal to 3, so dot at 3 to the right of 3. Or I want y to be less than negative 6, so open circle at negative 6 to the left. Again, two different branches going away from each other. And I'll take a number in one or the other branch. Okay? That's what the or means. Here's a word problem. Find all sets of 4 consecutive integers whose sum is between 10 and 20. All sets of 4 consecutive integers whose sum is between 10 and 20. Consecutive means one right after the other. Now we could figure this out with just guessing some numbers. That's boring and lame. We're going to do it properly. And we're going to do it with an inequality because we want it between two numbers. So we're following our 4 steps to problem solving. Number 1, define our variables. So let's let n be the first of these 4 integers, these 4 consecutive integers. N is going to be the first one, the smallest one. Okay? Well, if n is the first one, step number 2, let's organize our information. If n is the first one, well then the next one is going to be n plus 1. You know, say 6 is my first integer. The next integer is 7, next consecutive integer. So that's 6 plus 1. The one after that is going to be n plus 1 plus 1, or n plus 2. The one after that is going to be n plus 3. Those are my 4 consecutive integers then. N plus 1, n plus 2, and n plus 3. Now I want the sum of those, sum means add, I want the sum of those to be between 10 and 20. So I think I can write this inequality. The sum is going to be n plus 1 plus n plus 2 plus n plus 3. And I want that to be between 10 and 20. Now it doesn't have to be exactly 10. And in fact, if it's just saying between 10 and 20, then it can't be 10 and it can't be 20. So I'm stuck in the middle. 10 is less than that sum, which is less than 20. Okay, step number 3. Let's solve our inequality. So we've got 10 less than, well, n plus n plus n plus n is 4n. 1 plus 2 plus 3 is 6, so 4n plus 6 is less than 20. 10 is less than 4n plus 6, which is less than 20. It's a lot cleaner. I can solve that pretty easily. I subtract 6 from everything, so 4 is less than 4n, which is less than 14. Divide all 3 parts by 4, and I get 1 is less than n, which is less than 14 over 4, which is 7 over 2. Okay? We've solved our inequality. We've gotten the variable alone in the middle. Step number 4, let's answer the question. So find all sets of 4 consecutive integers whose sum is between 10 and 20. Well, what am I getting from number 3? I'm getting the range of where the first number can be. N is that first integer. it must be bigger than 1, and it must be less than 7 halves. Well, 7 halves is 3.5. So it must be bigger than 1, but less than 3.5. Well, that only gives me 2 and 3, because it's an integer, so it's a whole number. So n can only be 2 or 3. So I've got two possibilities. If n equals 2, then my numbers are 2, 3, 4, and 5. And let's check that. If I add that up, 2 plus 3 is 5, plus 4 is 9, plus 5 is 14, and 14 is between 10 and 20. Excellent. So that's one set of solutions. The other set if n is 3. And that's going to give me 3, 4, 5, and 6. Let's check it. 3 plus 4 is 7, plus 5 is 12, plus 6 is 18, and 18 is a number between 10 and 20. That works. Good. Now, did I find all of the sets? How can I prove that I found all of them? Well, really, it suffices to show that the next biggest set, which would be the one that starts at 4, is going to be too big. So 4 plus 5 plus 6 plus 7 show that that's bigger than 20. Well, 4 plus 5 is 9, plus 6 is 15, plus 7 is 22. That's too big. And we must show that the next smallest one, the one that starts with 1, is too small. So that 1 plus 2 plus 3 plus 4. Well, 1 plus 2 is 3, plus 3 is 6, plus 6 is 4. Plus 6 is 6 plus 4 is 10. And 10 is not allowed. We had to be between 10 and 20, so we couldn't be 10. So these are the only two possibilities, since we found all of the sets. Here are your immediate practice problems. Solve each inequality and graph its solution set. So write down both inequalities, solve them, graph them on a number line. And that is the end of section 2.2.